Hey everybody, I wanted to give you a 5-minute recap again about this graphic organizer of the unit circle. You'll be using it a lot going forward, so let's remember where all these values came from, so it's not just something you're memorizing, but you're understanding why they're important angles and where all the values came from. Okay, so the easiest way to remember this is think about the sun rotating around in terms of degrees. So if I'm thinking about that, I'm starting at 0 degrees, and then I'm going to go in my 90, so 0, 90 degrees, 180 degrees, 270 degrees, and then all the way back around at 360 degrees. I could also go around in 45s, so that's halfway in between. So 45, 245 is 90. Again, that's 135. Another 45 gets me to 180. Another 45 gets me to 225 degrees. So splitting each of my quadrants. Another 45 gets me to 270. Another 45 gets me to 315. And another 45 gets me all the way around to 360. Similarly, I can do that with 30 degrees, starting with 30. So 30, another 30 gets me to 60. Another 30 gets me to 90. Another 30 gets me to 120. Another 30 gets me to 150. Another 30 gets me to 180. Another 30 to 210. Another 30 to 240. Another 240 to 270. Another 30 to 300. Another 30 to 330 degrees, and all the way around. Next up would be radians. And if you've got those very common radian measures, we know it's 0 radians to start. And then I know it's pi for 180 or 2 pi radians all the way around. And again, I can go by those nice multiples. So let's go pi over 4s. Pi over 2 would get me to 90. 2 pi's over 2 is 180. 3 pi's over 2 is 270. And then again, I'll go by pi over 4. So pi over 4 is going to be 45 degrees. 2 pi over 4s is a half. 3 pi over 4 would be over here at 135. 4 pi over 4 is 1 pi. 5 pi over 4 is going to be that 225. 6 pi over 4 is that 270 again. And 7 pi over 4 for 315. At that point now, I've made it all the way around. Let's go by 30s. That's going to be pi over 6 as a common angle. 2 pi's over 6 is also known as pi over 3, or 60. 3 pi's over 6, that's pi over 2. 4 pi over 6 becomes 2 pi over 3. 5 pi over 6. 6 pi over 6, that's just 1 pi again, so that's 180. 7 pi over 6. 8 pi over 6 becomes 4 pi over 3. 9 pi over 6 becomes 3 pi over 2. We already got that one. 10 pi's over 6 or 5 pi over 3 if I reduce it. And then, of course, 11 pi over 6 for all of those radian measures. Now, remember the x and y coordinates here. We've got cosine of theta is going to be the y coordinate, and the sine of theta is going to be the cosine is going to be the x-coordinate, the sine is going to be the y-coordinate based on what we've seen before. Our main values here for 0 is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. And then as we went around, remember we could draw in these great little 90-degree triangles with a radius of 1, remember. That allowed us to use Pythagorean theorem or the 30, 60, 90 triangles to figure out that, oh, this is going to be 1/2 on the y and root 3 over 2 on the x. So root 3 over 2, comma, 1/2. And the great way to remember that is root 3 over 2 is bigger than 1/2 because square root of 3 is like 1.8 or somewhere around there. So keeping that in mind is going to be really important. And then symmetrically, the 60 degree is just that triangle flipped. So the 1/2 goes in the x-coordinate, the root 3 over 2 goes in the y-coordinate. And I can use this symmetry and the fact that my quadrants just change the values. So down here I get negative 1/2, or sorry, positive 1/2, negative root 3 over 2. Here I get root 3 over 2, negative 1/2. 45 degrees, the triangle now is a isosceles triangle, still with a radius of 1 or a hypotenuse of 1, and so I wound up with root 2 over 2 for those values for both the cosine and the sine. Because it's isosceles, I wind up with SOHCAHTOA with the same thing, the ratio being the same for the sine and the cosine. And again, I can use symmetry here to know that this is going to be a positive root 2 over 2, negative root 2 over 2. And I can fill out the other quadrants again matching up, if I'm thinking about it, matching up these values with these values over here through symmetry. Negative 1/2 on the x, positive root 3 over 2 on the y, and continuing to go through all of those values. As we work examples today in the lecture videos, you might be able to reference this particular unit circle or just reconstruct it kind of each time as we go. And again, over time, it's like riding a bike. It'll get easier and easier in terms of what you remember and what you don't. And then this is negative 1/2, negative root 3 over 2. Okay. Take a look at the actual lecture video as we start to kind of utilize this graphic organizer and become more familiar with it. Again, this was just a good recap from where we left off last week.